So before we go into the worksheet, of course, we need to talk about, theory part first lah. You all watch the video?
Of course.
Okay, that's good. Okay, we should have one more student, right? But not here yet, but we cannot wait. We're going to start. So if you look at solutions and suspension, all right, what you're going to learn, is actually to know the difference between them. Must differentiate and distinguish. What's the meaning of solute? Okay, what's solvent? And then what is solution, right? Show an awareness of the importance of factors that affect the solubility as well as the rate of dissolving of substances in homes and industries. Deduce the nature of solutions and suspension by simple lab tests. Then investigate factors affecting the solubility and the rate of dissolving of substances. Okay? So these are basically all about, solute, solvent, solution, and then suspension. So if you look at this first, solution, okay? To make up a solution, you need first a solute as well as a solvent. When they combine together, okay, you get a solution. That is provided that our solute can be dissolved, right? That is provided the solute can be dissolved, okay? And then this is the suitable solvent for the solute to dissolve in. Not all solvent can dissolve everything. You agree with what I mean? Yeah? So later we may even talk about other solvents used to dissolve other solutes. Okay, but in general, most of the time we talk about solvent, we are referring to water. Okay, for your level, let's talk about water only. So in this case, this is actually water, and this is copper sulfate. This chemical here is known as copper sulfate. And when it's dissolved in water, you call this the copper sulfate solution. All right, copper sulfate solution, very nice blue solution. Okay, and then take note, solution always contains both solute and the solvent. 3 types of solution you need to know. First one, dilute solution. What's the meaning of dilute? That means if let's say, sorry?
Thin.
You can say something like that. Okay, thin. That means let's say it's Milo. Okay, I don't like to drink Milo from certain places. For me, the iced Milo. I like to drink Milo from McDonald's. Why? How come not everywhere the Milo is nice? Because if Milo is too dilute, what happens? Tell me, you all like not?
No, it's not sweet enough.
Yeah, not sure, right? The taste is like, cannot make it, My life, I cannot. Life is so short. We must really enjoy ourselves. Of course, not enjoy it to the extent that you harm your own health, lah. But what's the point of drinking Milo that is so diluted? Might as well drink plain water. Okay, so it contains very small amount of solute. So imagine I'm talking about Milo now. Small amount of Milo powder dissolved in a lot of water. Not nice. Okay, then there is also this thing called concentrated solution. That means you put a lot of Milo powder in a small amount of water. This, yes, very nice. Okay, but sometimes if it's overpowering, like the Milo dinosaur, you all tried before?
No, but this
I like it a lot.
similar. I did that something similar at home. I put a bit too much powder and then it just like something like the powder just wouldn't get dissolved.
Yes, correct. And then it eventually it's like you're chewing some of the Milo, right? Correct.
Yeah, so this kind of Milo thing called Milo cube. I don't know.
Yeah.
What they
correct.
make it for.
Well, people just want to eat it like it's candy. I didn't bother. I just take the spoon, I scoop my Milo powder and eat it this way. I mean, what's the point of having Milo cube? Yeah, right. When you bite on the Milo cube, you'll crumble into powder as well. So might as well just, you are smart, you're thinking.
They
Okay.
also have Milo nugget, Milo bar.
Oh yeah, exactly. A lot of different products, but actually they're about the same thing, right?
No, not
So
really.
you're also thinking, and luck, good. Don't waste money on all these things.
No. Actually, some of them, it is, how am I supposed to say it? They
Sometimes
do
it
not
will
taste the
work.
same as the normal Milo. For example, the Milo cookie,
Uh-huh.
it tastes very, very good. It has like, yeah.
Mm.
So sometimes you need to consider a lot of things.
Yeah, the taste lah, the taste. Okay, now when Zixuan was talking about his Milo he made at home, right? Cannot dissolve anymore, isn't it? Okay, Zixuan, your Milo drink is a saturated drink. You know? Okay, why is it saturated? Because it contained the maximum amount of your Milo powder already. No longer can dissolve anymore. Okay, but the thing about Milo, we actually don't call it solution. Yeah, we don't call it solution. Why is that so? You need to learn the characteristics of solution.
Because light can pass through.
Light can't pass through. That's right. You learned in primary school also, I think.
But no, I just learned it.
You just did, but in primary school we went through that also. Solution
no.
and suspension.
No.
No. Okay. Right. Maybe, yeah. Probably the school I work in, we teach students a bit more. Okay. When a substance dissolves in a solvent, we say that substance is soluble in the solvent. Like, for example, sugar. Sugar in water. Sugar can dissolve, right? So sugar is soluble in water. But if I put sugar in maybe diesel, you think it can dissolve? Diesel is a fuel. Okay, it can dissolve. Yeah, so you try to stir, it won't dissolve because it is not the correct solvent, right? And then iodine actually will not dissolve in water, but it will dissolve in alcohol. So certain things dissolve in other things lah. Sorry?
You know, like Milo powder with like carbonized drinks. It's like soda water, pure soda water.
I never tried that, but we can try. Okay, we can try. But Milo, Milo is getting a bit more complicated nowadays. It's not as simple as last time when I was young, no. Now they have designed, they invented the Milo powder that can dissolve in cold water, right? Not when I was young, cannot know.
Then can you like carbonize Milo?
Carbonized Milo. I have this machine that will carbonize water. Okay, I have this machine that will carbonize water. Right? So I forgot what is the name now. Suddenly I forgot. Okay, there's a
we also used to have it, but then the we ran out of carbon.
You just go and buy the cylinder, the carbon dioxide cylinder.
Yeah, but that's I think the jar broke. To continue the thing, I think my dad said something is wrong with it.
Right, I see. Mine is still working. So sometimes when I don't like the taste of plain water, I will actually carbonize it. So it's a bit fizzy, you know? Yeah. Okay. Now, water is a universal solvent. Take note of this. Okay, if you're asked, what is the universal solvent? You need to know that it's water. Okay, because many substances actually can dissolve in it. Now, this is a new term I want you to remember from now on, up to even, if you're going to JC, up to JC, you must know also aqueous solution is a solution which has water as the solvent. If I dissolve something in alcohol, I cannot say that that is actually aqueous solution, it's not. All right.
If you dissolve something in alcohol, can you call it alcoholic solution?
At this level, yes, still can. But then when you talk about state symbols, right, in equation, then you cannot put aqueous. Yeah, state symbols. Okay, what's the meaning of state symbols? Maybe I just illustrate. For example, H2, hydrogen, exists as a gas, right? Oxygen as well. When they are combined, you get pure water. Pure water is a liquid. Pure water is a liquid. Okay? Then you need to balance the equation. To balance the equation, it is done this way. Of course, you don't need to know now. You only need to know in Sec 3. Okay, and just to tell you what's the meaning of state symbols. Now, for example, just now I have the copper sulfate solution, right? Okay, the state symbol will be aqueous this way. So if you see something like this, similar like this, now you understand what they mean. Yes or no? Anla? Still don't know. Okay, the
I was
bracket.
asking about whether you can call a
No, cannot.
solution made.
Yeah, so if it's alcohol, right? Alcohol dissolving something, you cannot put aqueous because there is no
No,
water.
I said alcoholic.
You said alcoholic solution
Yeah.
earlier.
Yeah.
When something dissolves in alcohol, you call it alcoholic. Then it depends on whether it is drinkable or not drinkable. There are many types of alcohol.
Okay.
Very complicated, right? Yeah, it is. It is. That's why I can't give you a definite answer because that might be wrong. You get what I mean?
Understand.
So yeah, as much as I want to teach you a lot of things, I know that I can't because of time as well as you have not reached that level yet. Okay? What if you accidentally write all that thing in your exam paper? Okay, when the solution is formed, solute particles are evenly and completely mixed with the solvent particles. All right? So this is the example of just adding in the solute into the solvent. So when you, let's say, after you start stirring and then dissolve, this is what you will see in terms of particles. They are evenly distributed. Okay, so if let's say this is my sugar, okay, and this is water, when they are evenly mixed, or they are stirred already, this is what you'll see. Okay, they don't cluster to one side. Understand? They don't settle at the bottom of the container. Right, so now my question is, do you think solutions can be separated by physical means? So maybe one example is sugar solution. Do you think it's possible to get back water and sugar again?
Maybe it just like evaporate, let the water evaporate and leaving behind the sugar, and then it's sugar solution, so you'll leave behind the sugar.
So if I want water, how do I get back the water? Can be done. Okay. Okay, it's actually known as distillation. All right. You imagine primary school, you've seen this experiment before. Okay, where you have a very big container. Yeah. And then inside here, you have a small empty container. And then this is, let's say, seawater or sugar solution. Then you have this plastic sheet this way. Remember, you put a stone here. So remember this particular setup. Okay, the water will evaporate and then touches the cooler surface, right? Lose heat and then condense. And then because of the way this is angled, the water droplets will then be collected here. Yes or no? And this is pure water.